knew it.
Okay, so we're going to pick up on 25 part B and talking about complex ion equilibrium. So some metals, when added to a solution containing a Lewis base, will form complex ions. The formation of these complexes is dictated by a formation constant called Kf. So yet again, another K. We have Kc, Kp, Keq, Ka, Kb, Ksp, and now we have Kf. But Kf means something is forming. So we're going to take a metal plus a Lewis base, and we form what's called a complex. And this is dictated by Kf, which is the formation constant. The colored solutions can be monitored using spectroscopy, so this should be making you think experiment 7. That's what we did. We took iron and we took thiocyanide and we made a complex, measured its absorbance by spectroscopy, and determined the, the mole to mole ratio of the compound. So now let's write a couple of equations based on what we're told. So the first one is to write the equation for the addition of copper 2 sulfate. So it's copper 2 plus sulfate 2 minus to water. So we have copper sulfate plus, which is a solid, plus water, which is a liquid, which is going to make copper sulfate, which is aqueous, so that's where the water comes from, which is also in equilibrium with copper 2 plus and sulfate ions in solution, because we know that it is probably slightly soluble. So the blue color comes from the copper dissolving in water to form the copper sulfate aqueous solution. Now once we take our copper solution above and we add a few drops of ammonia, so this should be more like experiment, I think it was 5, where y'all did Le Chatelier's principle, okay? And it results in the formation of a second solution on this page, seen here. And so we see that a precipitate forms, maybe it looks white or gelatinous, kind of jelly-like in the bottom, and then we have the supernatant solution on top. So what's happening here? Well, now I'm taking the copper 2 plus, which is my Lewis acid, and I'm taking my ammonia, which is my Lewis base, and I'm forming a adduct, an acid-base adduct. If you remember back to that definition we talked about when we defined Lewis acids and bases. Okay. Now I would not expect you to be able to predict the formation of this specifically. Okay, we're just practicing kind of what's happening in these equations. All right, so now at some point, if we continue adding the ammonia, eventually the precipitate will dissolve and a dark blue solution is formed. And so what is happening here? So as we continue adding, eventually we are forming more of the adduct, the complex ion product, which will result in the deep blue color that we see above. Why are transition metals most often seen to form complexes? Well, they readily form covalent bonds with Lewis bases, making them really, really great Lewis acids, making them very stable products, because remember, covalent bonds are very strong. So once we start adding the ammonia, it was very easy to start complexing it with the copper, and forming that deep blue compound. So now here is a table of KF values. Again, not values I would expect you to know or memorize, but values I would expect you to be able to use appropriately. So you can see here, unlike the KSP values, which were very small numbers, KF values tend to be much larger, meaning these are favorably formed. Meaning most of these reactions shift very heavily to the right to form products and consume the reactants. So the last question says to explain why, or not the last question, but the last question for this video. Explain why the complex formation can increase the solubility of a salt. So the formation of a complex ion, which a complex ion is what we form between the metal and the base, the adduct. Removes dissolved ions from solution. This then forces the reaction to shift to the right, if we think about KSPs, and dissolve more of the solid. So for example, if we had, let's see, AgCl, and this is its solubility. Okay, so breaking apart into its ions. And if I start adding ammonia, well, the ammonia is going to react with the silver because it's a metal and it's a Lewis acid. And it turns out that for every 2 ammonias, it's going to react with 1 silver to form this complex ion. Okay, and so sometimes you're going to see brackets outside, and I should do a little bit better at that. Brackets outside to protect the formula, like that. Okay, and then so then you can see here that adding the ammonia removes or decreases the, it's not right in highlighter, decreases the amount of silver because it's decreasing the Ag plus concentration. The reaction is going to shift to the right to produce more and maintain the KSP ratio of products and reactants. Okay, so that's how that works. So now we're going to take a break and we're going to do 2 examples where we see how this affects silver bromide specifically. So this will be the first video. You'll have 1 more video for lesson 25 and then you should be done.